Hello, happy 2020. I know you guys have really missed this time together. I just want to tell you some really nice things first before we get started. I'm real excited to begin our second semester of Flipped Classroom. I think first semester you guys saw that when you actually do the Flipped Classroom, it works best. So we need to keep that up. And then, for bonus, I painted my fingernails for y'all, which, doesn't happen that often. So you're welcome. It's a nice winter white for you. Yeah, and I didn't use nail polish. I did not use whiteout. So, anyways, we're going to start this year off with a fun lesson on exponents. So those numbers that we've been seeing at the bottom of our builders, and you knew they're exponents, but we hadn't gone over the exponent rules, and it would take a whole lesson for me to explain that to you, which is what we're doing today. So I've told you until now that we're going to skip that. Well, starting this week, we are not skipping that because we are diving into exponents. So we're going to just do that right now. We're going to go ahead and get started because we want to make sure that we don't take forever. I know you don't want to do this forever on a Monday night, first night back, ease back in. All right, here we go. So when you see, I'm going to zoom in here. When you see this, 3 to the second, okay? What that means is 3 times 3, right? That's 3 times 3. And we know 3 times 3 is, hope you're telling yourself right now, it is 9, yes. So you should know this is 3 to the second power means 3 times 3. Okay. Now, just because we have a letter here doesn't mean that we can't apply the same things here. So don't be scared of letters. That's a lot of what algebra is. You can solve just like you can for numbers. So what that really means, x to the fourth, it just means this. It means x times x times x times x. And we're going to keep it at that because we don't have a number there. If we had a number, it said x is 5, we could do 5 times 5 times 5 times 5. Okay, we could get an answer there. But we don't. We just have x. So all this means is x times x times x times x. That's x to the fourth. Okay? All right. And the last example here is going to give us some definitions. When you see this, x is the base. We call it the base. It's the big number. And then the little number that's raised is the exponent. Okay? Exponent. So let's keep going. Here's what we're going to break this down. Okay? X to the third. X to the third is x times x times x, right? That's x to the third. When you're multiplying that by x to the second, what you're really doing is you keep multiplying it and you have x times x. That's x to the second, right? So that really means you are doing this. You're doing x times x times x times x times x. 5 x's right there. We had x to the third and x to the second. We're multiplying those together. So we have 5 x's, which is really what? How could we put this in an exponent answer? Look how we did up here. 4 x's is x to the fourth. So 5 x's would be what? X to the fifth. Do you see what happens here? Did we multiply those exponents? 3 times 2, does that equal 5? No. What do you have to do to get 3 and 2 to equal 5? You add. When the bases are, when they're the same, or alike, when the bases are the same or like, that's what this means, like means same, and they're multiplied, you add, ADD, add the exponents. When the bases are the same and they're multiplied, you add the exponents. So let's look at an example here. X to the fifth times x to the fourth. Okay? That's going to, what are we going to do there? The bases are the same. We have 2 x's. So we are going to add the exponents. What's 5 plus 4. 9. This is going to be x to the 9th. Okay, ooh, number 2 is a little tricky. There is no exponent here. This is understood to be a 1. We just don't write it. We just put y. It's just y. So what would you think would be the answer here? Add your exponents, because the bases are the same. They're both y's. Y to the 8th. Okay? Okay, look, we're going to make it a little more tricky here. We're going to put some numbers out in front. So what you have to do here, it's a two-step deal. You have to actually multiply these, when you have a 4 and a negative 2 and they're multiplied, you multiply them. There's no adding, there's no exponents on those numbers themselves. There's an exponent on the x, but there's not on the numbers. So we have to do that part first. 4 times negative 2 is negative 8. And then we have an x to the 1 and an x to the 3rd. So if the bases are alike, which they are, they're both x's, we add those exponents. We have a 1 and a 3. That negative, it's not like distributed. You don't have to distribute that negative in front of the 2 to the exponent as well. So 1 and a 3 is x to the 4th. Negative 8x to the 4th. Alright? Look at number 4. Okay, number 4. So we're going to keep using those same rules. We're going to go ahead and multiply those numbers in the front first. Okay, negative 5 and a positive 3 makes a negative 15. X squared and an x to the 1 makes x to the 3rd. You add those exponents. Y to the 3rd and y to the 4th makes y to the 7th. Okay, number 5, we're still multiplying here. That's what that dot means. Hard to see, but that's what we're doing. We're going to multiply those coefficients in the front there. We have a 2 and a 4. 2 times 4 is 8. Then we have a to the 1st times a to the 3rd. Add those exponents. A to the 4th. Then we have, I'll color code that for you. Then we have b to the 2nd times b to the 1st. Add those exponents. That's b to the 3rd. And then lastly, we have c to the 3rd and c to the 5th. Add those exponents, you get c to the 8th. That's your answer. Okay, I know you guys don't have your calculators at home, but I'm going to grab one. We're going to figure out a pattern. In math, it's always helpful when there's a pattern that we can see. So we have, let's refresh ourselves on how to put an exponent into the calculator. Okay, you can either do it two ways. You could do the number housetop, that means raised to whatever the power is, just enter it in. That's kind of how I would say you should do these, because you're not always going to raise it to the second power. That's what this is. This x squared is, you would raise any number to the second power. So we're going to use the housetop, okay? So we're going to say 5 housetop 0. 5 housetop 0 equals 1. Negative 2, well, we'll go ahead and put those parentheses in just like it has it in there, housetop 0. If you have a calculator that you could do this on, please do that. Equals 1. What are you seeing as our pattern here? They're both 1. Why do you think they're both 1? What is the key that makes it 1? What do these both have in common? Is it their numbers in the front, the base? No, the bases are different. It's these exponents. Anything raised to 0 is 1. Anything raised to 0 is 1. So what's 1/3 to the 0 power? 1. What's x to the 0 power? 1. Okay, anything raised to 0 is 1. All right? Okay. Okay, let's look at these. This is going to be a new rule. Okay. I'm going to zoom in a little bit. This next part. Look at x to the third and x divided by x to the second. This means, we're going to write this out. X to the third is x times x times x, right? And we have a divisor, and then we have the bottom, which is x to the second power, x times x. Okay? So, when we write it out like that, we can have some x's cancel. These x's cancel. X divided by x is just 1. These cancel. That's just 1. So it just leaves us with x over 1, which is really just x, right? X to the first power, if we want to put an exponent on there. So what do you see here? Do you see any kind of pattern? Look up here, it might help you. When we went up here, when we had the same bases or multiply, we add the exponents. What do you think is going to happen when we have to divide, when the bases, when like bases, the same bases are divided? What do you think is going to happen? Look what we did here. We had a 3 and a 2, and we ended up with x to the 1. I hope you're saying subtract. When they're divided, you subtract the exponents. So let's look at some examples here. X to the 10th over divided by x to the second. Well, we both have x's there. And that's going to be 10 minus 2 is x to the 8th. X to the 12th divided by x to the 4th. 12 minus 4. We subtract those exponents. We get x to the 8th. X to the 8th. Okay? Look down, look at number 11. Okay? This one's a little tricky. I'm going to look what we see here. If we do 2 minus 6, it's going to leave us with a negative exponent. A negative exponent. Because x to minus 6 is x to the negative 4, right? We've never seen a negative exponent. Well, I'll tell you what happens. But first I want to map it out for you. So let's do this. X to the second is the same as x times x, right? And then x to the sixth, well, that would be x, 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 x. 6 x's. We can start to cancel some of these out. Yeah, let's cancel. So we end up with a 1 on the top, nothing else is left over. A 1, and then how many x's are left? 4 x's. 1 over x to the 4th. Okay? So you end up with, this becomes 1 over x to the 4th. Move that down for you. So if you have a negative exponent, x to the negative 4, you just move that whole thing down to the bottom of a fraction. If you end up with a negative exponent, the proper way to write it is with a 1 on top, and then you move that exponent down to the bottom. And it's the same thing. And I just proved that to you whenever we mapped out, we crossed out our x's. We wrote them all out, literally crossed them out. We ended up with 4 x's on the bottom. Okay, so x to the negative 4th is the same thing as 1 over x to the 4th. And that's the proper way to write it. This is the proper way. Okay, so let's look at 12. Alright, we have 12x to the 8th divided by 4x to the 4th. So 12 divided by 4, we can do that as a normal division problem. That's going to give us 3. X to the 8th divided by x to the 4th. We'll subtract those exponents, and you get 3x to the 4th. Okay. And then the last one, you can have a negative number, a coefficient in the front. That's fine. Negative 10 divided by 2 is negative 5. y5 divided by y1. Subtract those exponents. 5 minus 1 is 4. That'll be your answer. Negative 5 to the 4th. The only time you need to move it down to the bottom of a fraction and make it 1 over is if you have a negative exponent. We had a positive exponent there. Alright? So that's page 1. Now I want you to look at page 2. We're just going to do something really quickly. This isn't going to take as long as you think it will. We're going to kind of speed through this. Look at x squared to the third power. We have an exponent to an exponent. What this really means is this. X squared times x squared times x squared. Alright? Right? Because you have x squared to the third. So it's 3x squared. Alright, so what does this mean if we were to map this out with just x's? X, 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 x. So what is that? How many x's is that? X to the 6th. Okay? So what you do here, can you see a pattern between x to the 6th and these numbers? How could you take 2 and 3 and make 6? You have to multiply. When a power is raised to another power, you multiply the exponents. Only whenever you see one power raised to another power. This is not the same as multiplying x squared times x to the third. That's not what that says. It says x squared to the third. So you have a power raised to another power. You're multiplying the exponents. So here we have x to the fourth to the second. You're going to multiply those exponents and you get x to the 8th. 2x to the 5th to the third. Well, look at what you're doing here is you're doing 2 to the third power.
Welcome back. If you are available, we need all teachers in the cafeteria to help hand out schedules for the second semester. Please come down if you are available. We need all hands on deck this morning and in the cafeteria. Thank you.
If we broke this down, when we have this number here, it would be 2 to the third times x to the 15th, right? Because you have a 5 and a 3. So you end up having, what's 2 to the third? 8 x to the 15th. That's your answer. Okay? And then here we have negative 3 to the second, negative 3 to the second, x, which is x to the 1, and y to the second. Okay? So you don't multiply x and y together. Like you can't just get rid of the x. It's x is to the 1 power, so you have a 1 to the second power, you're going to get x to the third, to the second, because you do 2 times 1. Remember, we're multiplying, we're raising a power to a power. And then y to the 5th to the second power, so we're multiplying those together. 5 times 2 is y to the 10th. But we could simplify this even more, because we could tell you this is an answer. Negative 3 times negative 3 is 9. So let's rewrite this. And that would be your answer. That's a 10. Okay, so let's review again. If you have exponents that have the same base and they're multiplied together, you add. So you add the exponents, and this becomes x equals, this answer is x is to the what power? 5th power. Okay? If you have a power raised to a power, multiply, and you get 2 times 3 is 6. What was x to 0 power? Anything to 0 power? 1. Always 1. Okay? And if you have division, you have an x to the 6th over x to the 2nd, and they both have the same base, which they do here. They're both x's. You subtract. And you get x equals x to the 4th. And then finally, if you have a negative exponent, what do we do to make that proper? We put it over under a 1 and take away the negative sign. We just move it to the bottom. Okay? Okay, what I want you to try to do here is see if you could use our rules that we just went over and do 17, 18, 19, and 20. I want you to do them tonight. Do them tonight because tomorrow we are going to go over them. And this is a way for me to check to make sure you did the video and you are understanding what we're doing here. So please do these 4 problems. That's something new I'm going to be doing with videos this semester, is I'm going to leave you with some problems to do, and then I expect you to have them done when we come to class tomorrow. It's a way to self-check. All right? Have a good night. Bye.